I'd feel really bad for the soccer girls.
Recording for our soccer friends.
Hope they won.
That's right. They lost today. Hopefully they won. They win tomorrow. By the time they watch this, who knows? Integrating du over u. Okay, consider 1 over x dx. Does the power rule for integrals apply? I don't know. Let's try the power rule for integrals and see what happens. So the antiderivative of x to the negative 1. Okay, so we increase the power by 1 if we're going to use the power rule.
And then it's 0, then it's x over 0. Oh.
So the power rule would say increase the power by 1, divide by the new power.
Which is 0, and you can't do that.
Wait a minute, that's... I can't do that. So no is the answer. The power rule does not apply to the antiderivative of 1 over x. So we need to find a function whose derivative is 1 over x. And we've done a function whose derivative is 1 over x. Do you remember whose function has a derivative of 1 over x?
NaturalLog x?
NaturalLog of x plus c. So the antiderivative of 1 over x is the natural log of... Now, be careful, there's one minor change here. We put the argument in absolute value because you can't take the log of a negative number.
Because that would make it a lot messier.
Because that just doesn't work. So the antiderivative of 1 over x is natural log of the absolute value of x.
But if it's a positive number, can you just leave out the absolute value?
Yeah, well, be careful. When it comes time to evaluate, if you get a positive number in there, then the absolute values don't matter. That's right. These are the same thing. Maybe you can see that just dx over x. So, our brain is sort of looking for that, but don't be confused. This is the same thing, dx over x. A lot of times we'll use u substitution, and we end up with 1 over u or just du over u. And when we do that, that antiderivative would be natural log of the absolute value of u plus c. Out of room for the plus c. So, example 1. This is an easy one. So I can just move the 10 out front. And the antiderivative of 1 over x, just did that. That's natural log of x. 10 natural log, absolute value of x plus c.
And then we get to stuff like number 2.
And then number 2 happens. It's like, wait a minute, this is not the same thing.
And then you mess about u.
So let's let u be something so that du shows up.
5 minus 4x.
Probably 5 minus 4x, because that would put u in the bottom, and especially given the worksheet that we're on, the unit that we're on, we usually get u in the bottom. Du then would be negative 4 dx. So we've got some constant issues we need to fix here. I'm going to move the 9 out front and then put a negative 4 in the top and the bottom. In the top on the inside to make du, on the bottom on the outside to counter the negative 4 on the inside. So negative 9/4 antiderivative of du over u. So negative 9/4 natural log of u plus c. Are we done with this problem?
Nope.
What do we need to do?
Plug the x's back in. Plug the x stuff back in.
Plug the x stuff back in. Why did we not plug the x stuff back in yesterday? Like we're going back and forth between plug it back in, don't plug it back in, plug it back in.
Because this doesn't have limits.
Yeah. So if we had limits with that we could change to u stuff, we'd be fine. But we don't. We got to give our answer in terms of x. So negative 9/4 natural log, absolute value, 5 minus 4x plus c. Yes, sir.
So on like a free response, you'd have to put it back into x.
Yes. You would need to put it back in. You have to get it back in terms of x. That's a good general question. On free response, usually you have to substitute the stuff back in. Once you substitute it back in, you're fine. It's kind of the same way you can't leave f of 3 as a free response answer. Even if everyone knows, well, that just means plug 3 into f. Well, they want you to plug 3 into f. Number 3, that looks worse than number 2.
But it's not.
What do you think we should try for u?
The bottom part.
Probably the bottom, and then it's kind of a hope for the best situation here. Du would be 3x squared minus 6x dx. Well, that's not exactly what we have in the top, but it's close. It's good. It's a good close. Like if I multiply by 3, then we've got it. So 1/3 out front. Now all of that turned into antiderivative of du over u. 1/3 natural log, absolute value. This time I'm paying attention. I'm going to save some space and plug in the u stuff kind of on the fly. Save myself a little time. Okay, well, just as you think, I got it figured out, I just make u the bottom every time,
or
and
just
du magically shows up in the top. Here comes number 4. If you try that, and again, it's okay to guess wrong, so you're kind of stuck, not stuck, you're in the habit of letting u be the denominator. So you roll with that for a little bit, but probably not too long before you realize, wait a minute,
it's not nice.
that's not going to work. Like, okay, it makes the bottom nice, but that doesn't fit what the top is doing. So this isn't going to work. Thoughts on what we could do with that? It's algebra, not
You
u
have to make it the
substitution.
top, but then that makes it yucky. Because I've already attempted it.
Let's just split it up like this.
I forgot you could do that.
Split it up. As long as there's one denominator, you can put each numerator over the one denominator. Then now you got a whole lot easier thing to deal with.
Yeah.
So that would be x squared over 2. Uh-oh, this one's going to take a little bit more work. Maybe I need to slow down on this one. I'm going to rewrite it as x to the negative 1, because if I don't, I'll probably mess up the power rule.
Yeah, but then that's when you have to do u sub. Right?
Wait, I don't need to do that. X to the negative 1, that's 1 over x, that's the natural log. So minus 8 natural log absolute value of x plus c. I was going to do power rule, and then I was going to be dividing by 0. So
You were right, you did need to slow down.
I did need to slow down. But it's a good reminder that if you don't recognize it right away and you try to use the power rule, hopefully you pick up pretty quickly that, wait a minute, this is not applicable, or this
You'll
isn't
get kicked in the
eligible
butt.
for the power rule, because you end up dividing by 0, and then you think, oh, whoops, that was supposed to be natural log.
So there is no u substitution.
There is no u substitution for what?
You don't have to write
Ones
out
like
the u sub.
those.
I didn't need to. Yeah, I didn't need to. It worked out. Now, 5 is bad, because I can tell right away that if I let u be the denominator, that's not going to do anything for me for the top. Because then du would be dx, and I'd still have a mess. So that u sub is out.
That's
if you try to let u be the top,
It doesn't work out either.
3x squared minus 2, that doesn't do anything for us either. Okay, there's a rule that we got to know here, and that is if the degree of the numerator is greater than or equal to the degree of the denominator, we must divide.
Why?
Well, it's the only way that'll work, I guess, is one answer. Like I can't, I'm stuck. I can't do anything with this thing. Like I tried u being the top, I tried u being the bottom. Neither of those worked. The shortcut, it's not much of a shortcut, but the rule is if the degree of the numerator is bigger than the degree of the denominator, you've got to divide. Now, it's a pain today because dividing and then integrating what you get after you divide is a pain. But the real problem comes 3 weeks from now when you see one of these and you haven't seen one in a while and you're stuck spinning your wheels trying to figure out what u is when you forget the rule that, wait a minute, if the degree of the top is bigger than the degree of the bottom, I've got to divide. Okay, we have two options. If that's any solace for you.
No.
What are my two options? What am I talking about? Do you know?
Longhand or the
The long divide, or remember the name of the other one?
nope.
Synthetic division.
That.
You can do either one.
Long division is frustrating me, so
Let's do synthetic.
Well, I would think let's do synthetic as long as we remember how to do
I
synthetic.
couldn't remember, so I tried.
And this is a cruel one because it's missing an x squared term, so you've got to remember to put in the sort of x squared placeholder there. And if we're dividing by x plus 3, what thing goes out front?
Negative.
-3. Good. See, you remember something
No, I
about
don't.
synthetic dividing. Bring down the 1, multiply, add, multiply, add, multiply, add.
Can you explain, please?
All right, been too long since you synthetic divided?
Yeah.
Okay. Start by bringing down the 1.
Every time?
Every time. Whatever is that first number, copy it down.
Okay.
And that is, as maybe as silly as it seems, that is a frequent place to mess up because you remember the rest of the pattern, but you don't know how to get started. Bring down whatever number that is. Then you're going to multiply -3 times 1 to get that number. -3 times 1 goes there. And then you add, so that's multiply, then you add 0 and -3, and get -3. And then you just repeat. So we'll multiply by -3 to get 9. And then we'll add -2 and 9 to get 7. Multiply by -3. Add them together, get -14. So what do we do with those numbers? What is this? 1, -3, 7, -14.
X cubed minus 3x squared plus 7x minus 14.
Not quite.
What?
Landon?
X squared minus 2x plus 7.
Right, you're dividing x cubed by x, so you're going down a power. So it's x squared. Or you can start at the other end and know that last number is going to be your remainder. X squared minus 3x plus 7. But I don't want a remainder -14. I'd like to do the fancier thing with that. What is the fancier thing?
Isn't it -14 over x plus 3?
-14 over x plus 3. Man, we should have done a long divide, an old school long divide problem, like 4th grade long divide problem. Okay, side note, let's do 723, let's just make it 7231 divided by 4. So, little side note, you don't have to write this down, but you'll see some of the similarities, what's going on here. 4 goes into 7 one time. Multiply. 1 times 4 is 4, like that's the multiply step. Now we subtract. 7 minus 4 is 3. Over here we added, but the reason we switched it around is because instead of using x plus 3, we put a negative 3 there. That was the kind of the hidden trick there. Bring down the 2. 4 goes into 32 8 times. 8 times 4 is 32. Subtract it. Bring down the 3.
It doesn't go in.
It doesn't go. This is a good one. There's lots of weird things happening here. 0 times 4 is 0. Subtract. Bring down the 1. Let's see. 7 times 4 is 28. And then the first thing you did with those was say it's a remainder. The second thing you did with those was probably put 0.000 and keep bringing down zeros until something happened. Probably the last thing you did was say, wait a minute, I can now do the remainder over the divisor. Obviously this is more complicated, but it's the same, sort of the same procedure that went on in your 4th grade long division class.
Did we put R21?
Right, when you would put R3, stop there. Okay, so we did our long divide, but the whole point of this was to integrate.
Yeah.
Now we got to integrate all of that.
I don't want to.
Well, most of it's easy, so at least there's that. Alright, I got to integrate each piece, but the first 3 pieces are supposed to be easy. And since they're supposed to be easy, find out just how easy they are. We'll pick on people for the first 3, and I'll do the last one. So, Callista, what's the antiderivative of x squared?
X to the 3rd over 3.
Good. Belle, how about the antiderivative of negative 3x?
Negative 3x squared over 2.
Good. And Peyton, the antiderivative of 7? 7x. Alright, those are the easy ones. That's old school power rule, no big deal.
Now what about the last one?
Now what about that last one?
We got to bring the 7 plus or x plus 3 up to the top. Because you can't.
No, because if I bring it up to the top, the power rule doesn't work because it's to the negative 1. But that reminds me that it's natural log. So you could let u be x plus 3. And then du is just dx. Maybe we should slow down here. I'm going to move the minus 14 out front so I don't have to worry about it. U is in the bottom, du is in the top. And the antiderivative of du over u?
ln the
Natural log.
absolute value. That's what I was trying to say.
Natural log, absolute value of u, but I know what u is, x plus 3
Plus c.
plus c. Yuck, yuck, yuck.
So overstop it.
Not quite. Again, the rule that I should highlight is that if the degree of the top is bigger than the degree of the bottom, you've got a long divide, and then you know you're going to have not long divide, just divide, maybe long divide. It almost always turns into a mess like this. So if you're paying attention and you see the top is bigger than the bottom, you can exhale in disgust and then leave some space on your paper because it's just going to take a while. You got to do a pre-cal problem with the long divide or algebra problem, and then you got to do the antiderivative of all the pieces that you get. All right, we're going to do one more Then we'll stop. We'll leave the trig stuff for Monday. So number 6. What do we have to do with number 6? I mean, it's easy to know it now when we're talking about if the degree of the top is bigger than the degree of the bottom. You got a long divide. Oh no, what's different about 6 compared to 5? These crazy math teachers, they keep making problems more and more difficult as we go.
It's like that's the point.
So I'm not eligible to synthetic. That means I have to
Longhand.
got a long divide, which long divide shares a lot more similarities with 4th grade division than synthetic division does. So let's all jump back into the time machine and go back to 4th grade. The fond memories.
Mm-hmm.
I keep saying 4th grade. I don't know when you learned a long divide.
In the 4th grade, yeah.
So set it up just like 4th grade. Top numbers in the house. That's the dividend.
Dividend?
And the one outside is the divisor.
Yeah.
Not that you ever need to use those words ever again.
We didn't even need to
Our
use
answer will be the quotient. We don't need those words though.
Yeah.
So just like 4th grade, something times x squared gets me x cubed. Something times x squared gets me x cubed. I think that something would be x. And then we multiply it back. So x cubed minus 5x. And then just like in 4th grade, we'll subtract those things. So negative 4x squared plus x. Bring down the 20.
No likey.
And then repeat the process, just like we did in 4th grade. Something times x squared gets me negative 4x squared. No, negative 4 would work. So negative 4x squared plus 20. And then subtract, which just means change those signs. And that's kind of, well, it's not convenient that the first one canceled. The first one's always going to cancel because we picked them to match. So yes, those will cancel. It's kind of coincident fluke that the second one cancels over there, or I guess the third one, and we're left with just x. So we're going to do the antiderivative of x minus 4 plus x over x squared minus 5. And now it's like, well, what do I want to do first? I can handle the first two things pretty easily. So do I want to do those, or do I want to wait on those and handle the hard thing? I think we do the easy thing and get it done. And when I say easy thing, I mean definitely eligible for popsicle sticks. So, Alex, how about the antiderivative of x? Good. And Mia, the antiderivative of negative 4 minus 4x. And then we've got to handle this thing. Maybe I'll slow it down and even rewrite it. Thoughts on what u should be? Especially so that du would show up, or something like du would show up. X squared minus 5 for u. Du is 2x dx. So it's not perfect, but it's pretty good. It's pretty close. I'm only off by a 2. And we can fix numbers easily. So this becomes 1/2 antiderivative of du over u. Kind of being lazy and not writing down the previous stuff. So x squared minus x squared over 2 minus 4x plus 1/2 natural log absolute value of u, which is x squared minus 5. Oops, plus c. If the top's bigger than the bottom, you got to divide. Maybe synthetic, maybe long divide. And then the real fun begins, because now you have multiple things to antiderivative. Usually, one of them is a natural log. The last piece is almost always a natural log, because you end up with this remainder thing that instead of remainder, we're turning into a fraction, which then turns into a natural log. All right, the assignment is worksheet 3, 1 through 10. And then on Monday, we'll do the rest of this page and the rest of worksheet 3. Which doesn't leave a lot for Monday, but it kind of works out well. Monday's a national championship game if you're interested. So we're not, not blowing off everything, but
National championship game for what?
for college football. I guess TCU.
Yeah.
I don't